Hi, I am Sai Kiran of Section B with roll number 620250. My topic for today's presentation is bisection method and its application in the field of chemistry. Chemical kinetics is a topic I have chosen as the application of bisection method. Actually, chemical kinetics is the study of rate of chemical reaction. It tells how fast the reaction happens with respect to time. Many factors affect the rate of chemical reaction. Among them are concentration of the reactants, catalyst, and temperature. Arrhenius is the scientist which had developed the relationship between rate of the reaction and the temperature. Bisection method is a simple and robust algorithm. It has two main applications. One among them is to find the root of continuous function, and another is to find the local minima or local maxima of a unimodal function. The main drawback of the bisection method is it has very slow convergence when compared to other methods like Fibonacci or golden section search. Bisection method is applicable for only functions which are continuously differentiable. Continuously differentiable means the derivative of the function should be continuous. Here is the algorithm for bisection method. Firstly, we have to choose 2 points named as A and B. Let the midpoint of A and B be C. We have to calculate the derivative at values A, B, and C. If the value of derivative at the C is 0, then the function will be minimum at the point C. Otherwise, we have to compare the values of A, B, and C. If the values of derivative at A and C are of same sign, then the minimum will lie in the interval C comma B. If the values of the derivative at B and C are of same sign, then the minimum will lie in the interval A comma C. We will repeat this process once again. Again, we'll be calculating the midpoint of the interval a comma c or c comma b, and we'll be comparing these values. We will stop this process until the interval length is less than the tolerance. Tolerance is assumed to be approximately 0 or 10 to the power minus 6 or 10 to the power minus 5, like that, or if the value at the midpoint is 0. This method has many advantages. Among them are it has simpler implementation, it is easy to understand, it has high flexibility, etc. It has wide variety of applications in many fields like machine learning, solving differential equations, solving optimization problems, and solving signal processing problems. Limitations of bisection method. It has very slow convergence. It is dependent on the initial interval, etc. So here is a numerical example which tells how bisection method works. The objective of the function is to maximize the function in the interval 0 comma 2. So let us assume a as 0 and b as 2. So we'll be calculating the midpoint of these 2 points, which is 1. So in the first iteration, the derivative values at a and c are of same sign. So the maximum lies in the interval 1 and 2. Initially, the interval length used to be 2. Now the interval length is 1. So which is half of the previous one. So once again, in the iteration 2, we'll be calculating the derivative values at 1, 2, and 1.5. And 1.5 is the midpoint of 1 and 2. In this iteration, we'll be getting to know that the derivative values at 1.5 and 2 are of same sign. So the maximum lies in the interval 1 and 1.5, and 1.25 is the midpoint of 1 and 1.5. So in the fourth iteration, we'll be coming to know that the derivative values at 1 and 1 to 1.25 are of same sign. So the maximum lies in the interval 1.25 and 1.5. So we will be repeating this process until the derivative at the midpoint is 0 or the interval length will be less than the tolerance, and the tolerance is approximately 10 to the power of minus 5 or 10 to the power of minus 6, etc. In the 11th iteration, the width of the interval is less than 10 power minus 2. So we will be stopping the iteration once again. So the minimum lies in the point which is the midpoint of the interval. The main task of my project is to find the temperature at which the reaction rate is minimum. So here is the Python code for my project. Here function 2 refers to normal temperature function. It takes C as input and it returns the function value at C, and function refers to the derivative of normal temperature function. It takes C as input and it returns the derivative value at that point C. And bisection is a function which takes three parameters as the input: A, B, and tolerance. Here A is initialized with the value 0, B is initialized with the value 100, and tolerance is initialized with the value 0.0001. And we'll be calling the function by using this syntax. We'll be writing the function name and we'll be writing the parameters A, B, and tolerance. So in this bisection method function, we'll be having a while loop where inside there is a condition that the interval length will be greater than tolerance. If it is less than the tolerance, then it will simply exit from the loop and it will be printing these statements. So while loop will be checking the interval length. If it is greater than tolerance, then it will be entering into the loop. It will be calculating the midpoint and will be calculating the function value, or in other words, it will be calculating the value of the derivative at c. If it is equal to 0, then it surely implies it is a local minimizer of the 2D model function. So it will be printing that value c and it will be exiting from the loop. If it fails, then it will be entering into the else if block. If the product of the derivative value at c and derivative value at a is less than 0, then minimizer will lie in the interval a and c. So we will be initializing b value with c. So our new interval will be a to c, and we will be once again checking the while loop condition, which is the interval length is greater than tolerance or not. If it is less than tolerance, we will be exiting from the loop and will be calculating the midpoint, and it will be our answer. If the product of derivative value at c and derivative value at a is not less than 0, then it will be executing the else block. So in the else block, we will be initializing the a value with c. So the new interval will be c to b. So once again, it will be checking the interval length. If it is greater than tolerance, then once again it enters the loop and it repeats the process. If the interval length is less than tolerance, it will be exiting the loop and it will be printing the statements which are given below the while loop. We will be printing the value of the midpoint of the interval which is less than tolerance, and will be printing the value of the reaction rate at that value. These are the outputs which I obtained after executing the above program in my compiler. The temperature at which the reaction rate is minimum is around 99.99 degrees Celsius. The reaction rate is around 52.165. So this is the function for which we have to solve, or in other words, we have to find the temperature at which the reaction rate is minimum. This is basically the Arrhenius equation which have shown you in the earlier slides. Here T is nothing but the temperature in Celsius, and the value of E is around 2.71. This is the detailed code explanation of my program. Temperature function takes C as the input parameter and it will be returning the function value at C. Here the function represents the exponential function here, which is mentioned in the earlier slide. Derivative function takes C as the input parameter and it will be returning the derivative of the function at C. So here is the main code. It has a function named bisection and it takes three input parameters A, B and tolerance, which are initialized in the below program before calling the function named bisection. It has a while loop in it and it has a condition where interval length should be greater than tolerance. If it is true, then it will be entering into the loop, calculation of midpoint will be taking place, and we will be calculating the derivative value at A, B and C. We will be comparing those and will be reducing the interval accordingly. And when the interval length is less than the tolerance, then it will be exiting from the loop and will be printing the interval length midpoint. It also prints the function value at the midpoint of the interval which is less than tolerance. So here is the flowchart of my algorithm of bisection method, and these are the references I referred during my application.